Good evening, everyone, and welcome to our free content and strategy lesson. Welcome to Free Prep Week. We're super excited that you're all here joining us tonight. Really looking forward to our time together that we're going to have here, talking all sorts of things about the MCAT, and specifically tonight we're going to be talking about acids and bases. So super excited about that, and super excited that you're all joining us here this evening. My name is Petros Panasi. I'm the director of our pre-health programs here at Kaplan, also a veteran MCAT instructor, and I'm joined by a huge team of MCAT instructors. They're going to be here answering questions as you have them, and so really want to make sure that you utilize this opportunity to ask all the questions that you have about the MCAT, ask all the questions about the content that you're going to see regarding acids and bases, and really all the fun stuff. We're here to have fun tonight, learn some stuff, both about the MCAT, learn some stuff about yourself maybe, but more importantly, really kind of engage and lead into the material that we're going to be looking at here tonight. So on the note, since tonight's free, one of our free content lessons here, we're actually going to be selecting someone to receive a $100 Amazon gift card. So the first thing I want you to do right now, before we forget, is click on that link at the top of the chat. It says Kaplan DAWZG. Almost looks like Kaplan Dogs. It's the form stack form. You can go ahead and click on that and enter in your information. And at the end of the evening tonight, someone will be selected to win a $100 Amazon gift card. So that's pretty awesome. So go ahead and do that right now. It's super quick. It's super easy. What you'll also see at the top of the chat is a link to schedule time with one of our MCAT expert instructors to really kind of figure out what's right for you as far as your preparation and kind of what you need as far as your path. So that's what we're here for. I mean, we all teach and we all work for you to figure out kind of what's the right thing that you need to be doing to get ready for the MCAT. So if you want to set up some time to figure out what kind of course options are right, what kind of preparation path is right for you, you can go ahead and click on that link, and that link will stay there for the remainder of tonight. So feel free to do that. I do see from the polls that about 40% of you or so are planning on taking the MCAT in April or May. For those of you planning on taking it in April, that means it's a couple days away for you. So congratulations for those of you taking it in April, because it's almost over. And for those of you taking it in May, of course, there's still a little bit of time. And then I see another 30% of you or so are planning on taking it in June or July. So really exciting. I mean, this is, it's kind of the perfect time to be preparing, perfect time to be coming to an event like this. So definitely, use tonight for those reasons as we kind of go through these things. At the same time, it looks like about 72% of you are planning on applying this summer. So actually starting the application process probably in June when it opens up. So that's great too. That means you're all kind of, again, right in the right place. Those of you that are planning on applying next year or even testing later, it's good. You're here early. So you kind of you've got a little bit of more time, but at the same time, you can use that time for some planning. So what we've got on the docket for tonight, pretty straightforward, but also pretty resourceful for you. We're going to talk a little bit about the MCAT, and then we're going to actually transition over where you are going to interact with a fellow named John Linick. John is here, so he'll say hi to you in a couple minutes here. John is one of our, I don't even know how to describe it. Words can't describe John. John is one of our veteran MCAT instructors, one of our rock star MCAT instructors. He actually teaches on the MCAT channel, has worked on curriculum, oversees a couple of our intensive programs. So John is an all-around MCAT veteran rock star, and really somebody that you want in your corner to get you ready for the MCAT. And you're going to get to have a lesson with him here tonight about acids and bases. So I know he's looking forward to that, and you'll meet John here in about 10 minutes or so. So we're gonna have the strategy and content instruction. That's what that line is. And then when we're done with that, John and I and the team, so Mike and Mackenzie and Henry and Brian and Allie, we're all going to be here and actually walk you through a couple of opportunities as far as get some coaching, get your questions answered, as far as like what you should be doing between now and test day, and what's going to be right for you. Because here's the deal: we've all been through this before. Everybody has kind of a different story, different needs, different strengths and weaknesses, and we're going to help you figure out what's right for you. So as I said, this is all about you. It's all about getting your questions answered. So ask them away, and that's what we're here for. Use that chat, as it were, as we go through this. So first, let's just make sure that we all are on the same page as far as the importance of the MCAT. So we do a survey every year of medical school admissions officers, and we basically ask them to rank MCAT score, undergraduate GPA, experience, the interview, the letters of rec, and the personal statement as far as the importance of, in the medical school admissions process. And year after year, the MCAT score comes back as the #1 answer. And in fact, this year, it was a little bit more than 50% of the medical school admissions officers who we surveyed said that the MCAT score was the most important factor. And this isn't to say that the other factors aren't important. It's just that when you really think about how the MCAT fits into the admissions process, it's the one thing that is the same for every single student. Everybody takes different undergraduate courses at different undergraduate institutions. We have different experiences, different letters of recommendation. But the MCAT score, that's the one thing that we're all, the one standard that everybody is held to that is the same across the board. And so that really does help admissions officers to see what your potential is going to be as a medical school student. And that's why they place such a high value onto it. Now, the personal statement is a very important part of the admissions process. The reason why it ranks lower when it's compared to the MCAT score and to the GPA is that schools don't usually get to your personal statement unless your MCAT score and your undergraduate GPA meet their standards and meet kind of the needs that they're looking for. So really important to place the right amount of emphasis onto your MCAT preparation. Medical school admissions is usually kind of a holistic process, meaning they look at everything and making their final decisions, but that doesn't mean that they're looking at everything and making their initial kind of screens. And so the MCAT score really is that opportunity for you to show your potential for how well you will perform in their school's curriculum. So really important to kind of keep that in mind, as it were. I saw a great question come in from Kristen in the chat of whether or not admissions officers look more at your undergraduate GPA or at master's scores or post-bac, or master's GPAs or post-bac GPAs. Really what it comes down to, when you report your coursework on the application, you will indicate whether a course was an undergraduate course or was taken as part of a graduate or for graduate credit. Post-bac programs kind of are a gray area. They're graduate level in the sense, or they're postgraduate level, I should say, in the sense that they are, after you've completed an undergrad degree usually. But the way it works is you'll put your scores in, or your grades in, and then they're going to calculate your GPA the way they calculate the GPA. So they will choose certain courses. So there's something called the BCPM, which is the biology, chemistry, physics, and math GPA for undergraduate, and then they'll look at your graduate coursework as well. So it really just depends on how the school's looking at it. Bottom line is you want to have the best foot forward as far as GPA, but more importantly, and this is kind of the good news, if your GPA is a little bit less than desirable, you can make up for that with a stronger MCAT score. It's hard to do the other way around, but you can do it, because the MCAT, despite what we usually think of it being as kind of a weed out exam, which it isn't per se, it's an exam that is given to see what your potential will be. So it's really kind of a predictor of your success later on in medical school. Not a predictor of whether you'll make a good doctor, but a predictor of how successful you'll be as a, as a medical student. So that's the way that it works. All right. So if you got more questions about that kind of stuff, let us know. If they're good ones for the group, I'll definitely make sure to answer them as a whole. Now, as far as what's tested on the MCAT, MCAT's a really cool exam because unlike what you normally see in undergraduate courses, an undergraduate course, you get tested on kind of the subject area that you're being taught as far as the course goes, right? You take orgo, organic chemistry, and that's all you're going to see on the midterms and finals. Same thing with bio, same with chem. With the MCAT, it all kind of gets mixed together. So you've got the chemical and physical foundations of biological systems. You're being tested on chemistry, you're being tested on physics, you're being tested on biochemistry, you're being tested on general bio, all in one section. So there's definitely an integrated nature, if you will, as far as the subject matter and how one subject area can apply to a biological system. Take, for instance, the circulatory system. Circulatory system is a biological system when we think about it, but it really is rooted in physics. It's all fluid dynamics, right? It's fluids moving from a pump through a piping system through your body and then back to the pump. So, they will test you on physics topics in a biological system. The only section that doesn't have any science to it is, of course, or any previous knowledge for that matter, is the critical analysis and reasoning skills section. So that's where you're given passages and you're required to extract what the arguments are and make conclusions based on the information that was presented to you. It's a long exam, right? We don't normally take 7.5-hour long exams. Finals, for the most part, are 3, maybe 4 hours at most. So we're not used to taking long exams. So that's also part of your preparation. I know in my time preparing students for the MCAT, that's one of the big skills that oftentimes students don't anticipate initially, is how they'll have to work and develop their endurance. We've got you covered on that end for sure, in terms of getting you ready for that. But it's a long test. It's a long day. And I think you'll all agree with me. Tell me in the chat if you agree with me on this. We don't like taking long tests, right? This is not, definitely not a way to do it necessarily. We like to, take things slow sometimes. But on the MCAT, you're literally being thrown with all these things all at the same time, all on the same day. If you look at the kind of breakdown as far as scores are concerned, the MCAT, it's an exam like any other that is scored, and it is scored on a curve. Now, we call this the MCAT 2015 total score. Don't worry, that doesn't mean that this is 3 years out of date. MCAT 2015 is kind of the name given to the current version of the exam because it was first released in 2015. But the bottom line is, as far as the scoring goes, plain and simple, what it comes down to is that you've got 4 sections. Each section is scored from a 118 to a 132 with the average at 125, which means the combined average score is a 500. That means that's the 50th percentile. It means half the students who take the test score above that, half the students who take the test score below that. You, of course, want to be above the 500. It's not to say you can't be admitted with a score below 500. And there's also nothing that says that you're guaranteed to be admitted even if you have a perfect score, right? There's so many other factors that come into play. But, keep in mind that you want to be higher on the scale or as high on the scale as you can be. But what's also important to remember is that since it is an exam that is scaled, it's curved, small improvements can actually reap big rewards as far as the score goes. You get a couple more questions right, and you can be jumping 1 or 2 points, especially in kind of the meat of the curve. So really important to kind of keep that in mind, is that you can make little tiny improvements as far as your performance and actually, see much bigger rewards as far as the overall score is concerned on the test. So something to keep in mind as you're preparing. Really, and agree with me or disagree with me on this, but I'll tell you this much. As students, myself included, we get fixated on scores, right? That is just a natural order of things. As people, we get fixated on scores. I want you to keep in mind, though, that you really want to not necessarily just keep fixated on scores. You want to be fixated on getting more questions right. So that's an important thing. So tonight, when we look at acids and bases, how do I get more questions right about acids and bases, right? How is it that I'm going to get more things right in that topic area? So really important to kind of keep that in mind, as it were. Last thing I'll say before we switch over to John here, as far as the science content, I alluded to this earlier, but I'll say it one more time and show you the distribution of this exam. If you look at the biological sciences section, biological foundation section, you'll notice you've got bio, you've got biochem, you've got GChem, and you've got OChem. But then in the chemical and physical foundation section, you've got GChem, you've got OChem, you've got physics, you've got biochem. You've got, these subjects don't show up just in one place. So acids and bases, classic example, one we're going to look at here tonight, they do form the foundation for most of biochemistry. This is, acids and bases and good old organic chemistry. Same thing goes, it's going to show up in the chemical and physical foundation section, right? There's a lot of acid and base chemistry in the biological sciences as well. So really important to kind of verse yourself across the board and be ready for this integration. It's something that we teach our students as part of our preparation, as part of our program here. So we're excited to share that with you here tonight. But if you got questions about this, feel free to let us know. This is information that is publicly available. It's on our website. It's on the AMC's website as well, as far as the distribution of the exam goes. Now, when we switch over here, and John's getting ready to teach for us, so we're going to switch over here to John here in a second. But something I want you to be mindful of when it comes to the MCAT is that, yes, there's content that you need to know, but then there are also all these MCAT skills that come into play. So science knowledge is part of it, but really being able to do well on the MCAT comes down to being able to apply the science that you know. So they might throw it to you as a problem-solving question. They might throw it to you as a research design question. There are all sorts of ways that they're going to intersperse these skills along with the content areas. And you're going to see a lot of that here tonight when we go through acids and bases, is that it's really about the intersection of science content and these MCAT skills that comes into play as far as improving your MCAT score. So really, as you're preparing, you need to be focusing on how well you can apply the content that you know and be able to and take it to the next level, as it were, and as it's going through. So a couple notes on that and something to keep in mind as we move through this. So with that said, I am going to hand the reins over to John. So we're excited. So John's going to teach for about an hour or so. This is actually acids and bases. We call it acids and bases, a primer. This is actually a lesson from the MCAT channel. We'll tell you a little bit more about the MCAT channel throughout the course of tonight. But after John's done, we're going to come back and we're going to talk about kind of what you've experienced and then talk about kind of the best ways to prepare, right? The best ways to prepare and really how to time out yourself between now and test day. So we're going to come up with a good plan for you. That's what we're all here for, to get those questions answered. So with that said, I'm going to hand it over to John, and we'll see you back. And we're also going to select the recipient of that $100 Amazon gift card later on tonight. So stick around for that as it goes.
Hey everybody, welcome to your free acids and bases class. How are we doing this fine evening? It's always nice to get some time to hang out with Petros and all the other teachers, so super fun. Cool, sounds good, guys. But welcome, thanks everyone, I appreciate it. So as Petros said, we're gonna dive into one of the exceptionally important topics for the MCAT, acids and bases. And now you might say, huh, that's weird. Acids and bases, it's pretty gen chem. There's a lot of biochem, there's a lot of physics, there's lots of other stuff in the MCAT. But the thing is, what they often do is they will test more advanced concepts like amino acid chemistry in your biochem, but use acid-base chemistry as the foundation of those questions. And so what we're going to do today is basically give a rundown of the kinds of essential things you need to know to make sure that you're prepared for any kinds of questions that get into this topic. So, all right, let's get this party started. And so what we'll do today is we'll just talk about the general ideas of what makes acids or bases strong. We're going to really break down the difference between strong, weak, and inert for acids and bases. This is one of those things that I feel the vast majority of people in college classes walk away taking some misconceptions from. And so we'll kind of really make sure we're comfortable with the concepts that are important there. As you can see, we're also going to talk about some more calculation-based things like gram equivalent weight, normality, and then we'll do a couple questions at the end that focus on those. Perfect. All right, so we'll start by just talking about what makes an acid or base strong. And so let's pass that question to all of you. What is it that is true about strong acids? Like, what makes an acid, at least if we were going to call it a strong acid, what characteristic does that have that makes it a strong acid? And so as everybody says there, totally true, acids have one job, or at least if we define them as an acid, it's got one major job, It's to give protons off. And so if an acid's going to dissociate into protons, exactly as Megan's saying, they're 100% dissociation, completely dissociates in water. That's what it's all about, which results in a low pH. And so I really want to break down a couple different things that people said here in the chat, because whenever we talk about pH, actually, let me just type this right here, because this is, I think, one of the biggest misconceptions that most test takers have going into this. When we talk about pH, pH is a property of a solution. So L-U-T-I-O-N, there we go. And so you don't have a pH unless you have a solution. As lots of folks here said, Anthony was the last one that said it, pKa or Ka, so Ka, I'll say slash, so pKa and Ka are the same thing, just one's a negative log. Don't worry, I'm going to spend a lot of time with you all talking about negative logs, how to approximate them as well. But those Ka and pKa is a property of an acid. And I'm going to say as in the molecule itself. So just be aware of that. There's no such thing as an acid with a low pH. An acidic solution has a low pH, and a strong acid will, in fact, drop the pH of the solution, as you all said. But just be really careful because the MCAT loves to split hairs on these kinds of things. And so keep that in mind. You don't have a pH unless you have a solution. You got to have it, your acid mixed in with water so it can dissociate. And yeah, as Teresa's saying, the key there, and that's what Miguel pointed out as well, is that the whole property of what makes this thing either dissociate or not dissociate is how stable the conjugate is. And so let's give a classic, we'll give a classic example. If you have a favorite strong acid, feel free to put it in the chat. I feel a lot of us have different favorite strong acids. But one of my personal favorites, as lots of folks are also saying there, is hydrochloric acid. And so one of the reasons that this is such a strong acid is because that Cl- is incredibly, incredibly stable. Excuse me, got something in my throat. But it's incredibly stable all by itself. Yeah, I've noticed like the first three people say HCl. And so the reason this is so stable is because it has a complete octet. It's also really big. And so we'll spend some time talking about strength here. Actually, no, let's just do it right now. This is the beginning of the class. I'm going to teach you all the secret to everything in all of chemistry in general. And so here's the secret to everything in chemistry in general. The more something can delocalize its charge, I'm just going to type this on the screen. So the more something can delocalize its charge, the more stable it will be. This is not just Gen Chem, this is OChem, this is reaction chemistry, this is biochem. This is kind of a foundation of a lot of different things. But the idea is the more you can delocalize charge density, the more you're going to stabilize that charge density. And so now there's a lot of ways you can stabilize charge density. So you guys let me know in the chat. What are some ways that you could take a negative charge and actually make sure that it's going to be, as you can see, delocalized, thus stabilized as well. And the reason I love asking this question is because one of the most common answers in all of organic chemistry is this, as you guys are saying, resonance. Resonance is a super, super good way to stabilize negative charge. But you can only do resonance if you've got a couple different atoms bound together. So if we're looking at really simple acids, we'll start with HCl versus HF as our two different examples, just for here. Notice we're doing this just to kind of give the foundations of the most important chem ideas before we get in. And so notice in these cases, we have no resonance to speak of. There's just a single atom with a negative charge. But the big difference is if you look at chlorine versus fluorine, chlorine is a massive element comparatively. And if you've got a large shell, if it's just a bigger atom, you've got more locations in which you can move that charge density around. Thus, it's naturally more delocalized just because it's bigger. Whereas fluoride, if you look at this one, fluoride is tiny, and that's a very ugly F that I drew there, but we'll circle around it. It's so little that you're forcing all of that charge into one tiny little spot, which means it's going to be really, really unstable. It can't really move its charge around as everything wants to do. Exactly as Brian's saying, they're a great way to break it down, Brian, in the chat. And yeah, that's right, on a gradius, Ruby. Let's label these real quick. And so then, as you said before, if we describe hydrochloric acid, this is in fact a strong acid. It will fully and completely dissociate, whereas HF is actually a weak acid. Yes, that's true. It is a weak acid, not a strong acid. That doesn't mean it's not dangerous. It's exceptionally dangerous. In fact, I'd say it's more dangerous than HCl is, but it doesn't fully dissociate, and that's what we're talking about when we call things strong, weak, or inert. And that's the definitions we're going to spend a lot of time with today. Cool. And yeah, Quinoa's got a great little mnemonic there. Atom resonance induction orbitals. Super rad little mnemonic for all those factors kind of tied in. Dig it. Yeah. All right, so I'm going to erase this, but I just wanted to spend a little bit of time before we got into acid-base chemistry specifically to show how this is just another example of the fundamentals of Gen Chem when it comes to stability or instability and what that means. Cool. All right. Perfect. All right, so I'm going to erase this stuff, everything we have here. And so as we said before, what makes an acid or base strong is that it completely dissociates in an aqueous solution, right? You need to have a solution to have a pH. And so Ka is known as the acid dissociation constant. Before we even do that, let's just talk about K in general. And so if you ever see K, what does K stand for, or what does K mean? Or even how can you solve for K? There's a lot of questions built into this, but there's a lot of ways you could say it. So I'm gonna draw something really silly while you guys are answering that. But I'm gonna draw this K here. This is gonna be an involved example. I think you'll all enjoy it. And this K is going to have a bunch of leaves on it, palm leaves specifically. But as you can see, Megan saying the same thing, Miguel, so it's the equilibrium constant. And as Ash pointed out there, it is the concentration of products divided by the concentration of reactants. That is every K. And there's lots of different ways that you can describe K. It could be Ka, it could be Kb, it could be Ksp, it could be Keq. These are all examples of this K term. But they're always solved for in terms of the concentration of your products divided by the concentration of your reactants. And I don't think anyone mentioned this yet in the chat, but what is never included in any of these K calculations? And you'll notice why I'm doing this silly picture in a second here. So there is a couple factors that we never include, and those are exactly pure liquids and solids. We don't ever include pure liquids nor solids in these K calculations. Exactly. Cool. So now you might be wondering why I drew this little K with a bunch of leaves on it. It happens to be brown. It's next to some really pretty blue water. And the reason I'm drawing this very random looking picture on the screen is because I want you to, whenever you see the letter K, imagine it shaped like a little tree. And that little tree just so happens to be, as you can see, a tropical tree. It's a nice beach, paradise. It's this place that everyone wants to go to and just hang out. In fact, I'm going to draw a little person here just laying on the beach, having a good time. We're going to say they're even smoking a stogie. That's right, hanging out on the beach, living the dream. And so when you see K, this is where we want to go to. This is our paradise. This is the ideal. This is, once we get there, we're just going to try to stay forever and hang out, because that's what K actually means. It's where every reaction is trying to get to. And once it gets there, it just chills and stays put. Much like if you're going on a beach vacation, you're probably not going to go on a lot of adventures. You're probably going to sit on the beach, read a book, swim a little bit, and mostly just hang out. So that's a silly picture, but it helps people remember it. And there's also another reason that I happened to have this person smoking a stogie, because in fact, it's not a stogie, but if you look at that right there, it's actually another letter. It's the letter Q. And so when we describe K, it's often in contrast to another term known as Q. And perfect. And so Q describes, it's you. It's like you are the Q. Q could be anywhere. You could be in the office. You could be in front of your computer watching free MCAT on captest.com. But the thing is, no matter where this Q is, wherever you are, you're trying to get to that K. And it's the same thing in reactions. Q describes any point in time, whether it's acid-base, equilibrium, solubility, same idea. But all of those reactions are trying to get to that K tree. All right, so there's my silly example, but it really connects together a lot of the stuff that we'll be talking about today. So I want to draw some pictures and have some fun here and give you guys something to take away more than just acid-base chem but chemistry in general in terms of these big relationships. Right, Brian? That's what we're trying to do. It's just, I guess spring break just happened for many people, so it might be bringing back some pleasant memories of what just occurred. All right, so I'll erase this, but that is a big idea. Remember, it's concentration of products divided by concentration of reactants. And one of the great things is, I guess I can just move this over for now. Whenever we're talking about any acid or base reaction, acid-base reactions are always, or I guess acid reactions, we'll stick with acids for now, always do the exact same thing. You've got some kind of a thing with a proton, and it dissociates into its proton and its conjugate base. And so if you ever look at the Ka, I'll just make this K tree into a Ka, it's always going to be equal to the concentration of your products, as we said before, which is your protons, times the concentration of your conjugate base, divided by the initial concentration of your acid. And so every single K expression, I don't care if it's sulfuric acid, phosphoric acid, hydrochloric acid, acetic acid. Whenever we talk about the K expression for any acid ever, even your diprotic and triprotic ones, it's the exact same formula. Concentration of protons times conjugate base over the initial concentration of your acid. Cool. All right. Whew. All right, so that's our dissociation constant. We've got it there. I'll leave that part on the screen for now, but we'll erase this pretty beach vacation so we don't have to get too distracted by memories of spring break or whatever else you might have been done in your previous beach vacations. But so as we said before, the stronger the acid is, the higher the Ka is, because the higher the Ka you have, the more protons you're going to get. Kind of straightforward, as we said before. Bases are the exact same thing, but when you solve for bases, you're not solving for protons, you're solving for hydroxides. But it's the exact same idea. So it's the same formula for Kb. The only difference is that you'd swap out that that proton for an OH group. That's kind of sloppy because they covered it up, but you see what I mean. And then, of course, you'd also have a conjugate acid instead of a conjugate base. All right. So same thing for bases, though. They'll completely dissociate in the exact same way. Cool. And so you already gave a bunch of your favorite strong acids in the chat. I'll give you the full list of the 7, though. And so these are the 7 strong acids that you need to know for the MCAT. These are the acids that fully and completely dissociate. Most of us know a lot of these, but I want to do one real quick naming convention. That's another kind of big picture takeaway that you guys can take away from today. What's the name of this acid? The one I just put that black box around, the HNO3. Because I'm going to describe it in contrast to another acid that is very similar. And it is a good call, nitric acid. And so the cool thing is this naming convention is true for all acids. Nice call, team. So that is nitric acid. If you have a slightly less oxidized form, this HNO2, that would be your nitrous acid. And so this isn't true for just nitric and nitrous. It's also true for things like sulfuric acid or sulfurous acid or chloric acid or chlorous acid. Anytime that you have a less oxidized version, it's the us version. So ics are always the most oxidized, us's are less oxidized. That's true for everything. So kind of like how we're doing big picture stuff, right, with the K thing. It's not just Ka. It's kind of all of chemistry has these common themes. All right, we got a list of a couple of common strong bases here as well, but once again, the major takeaway is the exact same. Whenever we're talking about these, we're talking about acids that fully dissociate or bases that fully dissociate into the hydroxides. So same idea. All right, so let's keep on moving and talk a little bit more about what this looks like. And so here's an example. Does anyone happen to know the name of this acid? It is the main ingredient in just vinegar, so we actually see this quite a bit. At least vinegars, I think maybe 5 to 10% of this. But nice, it is acetic acid, and so acetic acid is another common acid that you will see on the MCAT, otherwise known as ethanoic acid, if you want to use your full IUPAC nomenclature. And yeah, so that's our Ka. And this is a weak acid. And so if you look at the Ka value, it's 10 to the -5th. This isn't super strong at all. In fact, it's not one of the 7, so it can't be a strong acid. It's got to be a weak acid. And so what we're going to do is we're going to talk about strong and weak and conjugates and the relationship that we have between them. And so here's your hydrochloric acid. We talked about it before. It's super strong. In fact, if you have a strong acid like hydrochloric acid, we don't even bother dealing with its Ka value. So I'm going to cross that out because in all honesty, you don't really care. All you'll say is that this thing is 100% fully going to dissociate into your protons and conjugate base. And so you don't ever really have to calculate Ka values for strong acids because they just fully dissociate. So it's easier than math, thank heavens. All right. Let's do a quick little question for everybody. And so if you have a strong acid, well, how about this? If you have a weak acid, what is true of its conjugate base? And so this is one of those things that I feel most teachers kind of skew people's perception in college classes. But so if you have a strong acid, it will not have a weak conjugate base. I know that people say that in college classes, but it's not true. Just as if you have a weak acid, it will not have a strong conjugate base. It's as Megan and Annette and other people are saying, weak acids actually have weak conjugate bases. That's true. Weak acids do have weak conjugate bases. I know this might go against everything you learned in college, might have just changed your perspective on the world, but I'm going to show you why this is true mathematically. Because the thing is, if you ever look at an acid and its conjugate base, so let's look at these pairs right here. You probably noticed that looking at these numbers here, actually it doesn't have on the screen there, but the thing is that if you ever look at an acid's Ka and its conjugate base is Kb, these two will always multiply to give you the exact same value. And what is that value? I know, right? Don't worry, we'll show you more and we'll make sense of this, but seriously, weak acids do have weak conjugate bases. Strong acids don't have weak conjugate bases. Strong acids have inert conjugate bases. If you have a strong acid, that, as we said before, that means this thing is going to fully and completely deprotonate. It's going to dissociate fully because this thing is so stable. You would never call chloride a weak base. Like, think of the ocean. It's chock full of sodium and chloride, and it's not a basic water base, right? It's a bunch of chloride. It's inert. It's just a salt. It's a spectator ion. It's not a weak base. When you call something a weak base, that means it's going to actually act as a base. It's going to steal protons. And chloride's not a weak base. It isn't a base at all. It's inert. And that's the main difference that people tend to memorize in college, is that people will just rogue memorize strong acids have weak conjugate bases, weak bases have strong conjugate acids. That's just straight up not true. What is true, and I'll put this on the screen here, and because this is the idea behind that teachers are often trying to get at, but we tend to oversimplify the statement. But it's the stronger, it's relative, right? Everything's on a spectrum. It's all relative. It's not like hard definitions. But so the stronger the acid is, the weaker its conjugate base will be. That is a true statement. Just as you could say the weaker an acid is, the stronger its conjugate base will be. But if you look at acetic acid, you can see here, its Ka is 10 to the negative fifth. If you look at its conjugate base, acetate, it's 10 to the negative ninth. That's 4 orders of magnitude weaker than acetic acid. So, like, you cannot say this is a strong base. It's weaker than acetic acid by a significant margin, 100,000-fold, right? 4 orders of magnitude. And so that's, I think, one of the biggest misconceptions people have. And so don't memorize it as strong equals weak and weak equals strong. It's the bottom. The stronger an acid is, the weaker its conjugate base will be. And you could say, and this is definitively true, anytime you have a truly strong acid or strong base, its conjugate will be inert. That's the true statement there, because if something is by definition strong, then it fully dissociates, so its conjugate has to be more stable. Whew, how are we feeling so far about this? Because this, I know we just totally changed people's perspective of the world on a couple different concepts, and it's not that everything you know is a lie. Sorry, Anthony, it's not that extreme. It's just that it's a spectrum, right? It's relative relationships. It's not that it's like hard definitions. It's the main thing that we're really getting at here. All right, cool. right? All right, we'll do more. Let's do more. Perfect. Let's keep doing this. All right, so here's another example. Right, plot twist. Look at me, you got it. Cool, thanks, Hannah. This is why we do this. It's fun to, like, the light bulb moment is one of those really fun moments for us teachers, so we dig it. All right, but so here's another example. As I said before, just to give you naming conventions, we'll try to tie everything in here. So this is acetate, because that's the conjugate base of your acetic acid. That's also another convention that's always true. Anytime that you have an ic acid, as you can see labeled here, it will give you an 8 conjugate base. Just as sulfuric acid gives you the sulfate conjugate base, or nitric acid gives you the nitrate conjugate base. Yeah, basically that's yeah. So that naming convention is true across the board. Let's do a quick other one just to make sure that we're all really good with our nomenclature. If you have an us acid, anyone know what its conjugate base would be called? So every ic acid has an 8 conjugate base. I'll label that ic acid 8 conjugate base. Nice. Just as all of your us acids will have your ite conjugate bases. Cool. And that's true for everything, right? Nitrous acid has the nitrite conjugate base. Sulfurous acid has the sulfite conjugate base. Nice call, everybody. So that's true across the board. So we'll try to do that. Whenever things are just always true, we'll try to focus on those to make sure you can take the takeaways that aren't just random exceptions. All right, so there's your acetate. And as we said before, we solve for both of those. But it's another example. Strong acids have inert conjugate bases. Strong bases have inert conjugate acids. And so here's another cool example. I'm looking at ammonia and its conjugate base. Notice this is a really, really, really strong base, right? NH2 minus, it's a really strong base. That thing's super reactive, very unhappy. Nitrogen does not want that negative charge. But its conjugate acid isn't an acid at all. Notice the conjugate acid of this strong base is ammonia. And ammonia is definitely not an acid. That's why it's known as an inert acid, because it will never function as an acid. It's never going to give off its protons. If anything, as you know, ammonia functions as a base itself. So that's why if you're going to define it as the conjugate, you would define it as inert. Just to kind of come full circle with all that stuff we talked about on the previous page. All right, and this is the reason why. And I don't know if people, actually no one said in the chat yet, but you might have noticed, if we were to look back at all of these values, let me know if you noticed what the product would be if you ever multiply an acid by its conjugate base in terms of the Ka value of the acid times the Kb value of its conjugate base. And you'll get the same answer if you do the acetic acid and its conjugate or the hydrochloric acid and its conjugate. No matter how you do it, it is always going to be equal to the same number. Glad to hear, Kashiana. And that's what we get with water. So the autoionization of water is 10 to the negative 14th power, as everybody's saying in the chat there. And that's exactly why, as Alexandra said, good call, if you ever take the Ka of an acid and multiply that by the Kb of its conjugate base, you get the net reaction of just water autoionizing. Notice when you line up your acid reaction with your base reaction, cross out reactants that are on both sides. This is your standard, like turning a mechanism into a net ionic equation. So that means your net ionic equation for any acid and its conjugate base is just water autoionizing. That's why the pH scale is out of 14. It's not that we randomly chose 14 as a number to make our pH scale out of. It's because it's a property of water. All of the systems that we use are based on water. So to give a couple examples, 0 Celsius is freezing water, 100 Celsius is boiling water. 1 gram of water is exactly 1 milliliter, just as 1 milliliter of water is exactly 1 cubic centimeter of water. Everything's based on water, and so this is another example on why the pH scale is out of 14. It's just a property of water. We use that to base most of our foundations on, because as you know, water is very, very, very important for life. And so we kind of use it as our foundation for lots of things. Cool. Nice. And Brian's got the recaps there. Definitely know those two. Anything that deals with water, you want to know for the MCAT. So all those constants that Brian put in the chat, as well as, of course, freezing and melt or boiling, as we said, for water. But all those properties are real important for the MCAT. You get a lot of questions that deal with water. Usually it's through things like fluid dynamics and like Bernoulli's equation or Pousser's equation, if you want to get fancy, or buoyancy. But you do see a lot of water stuff. Cool. All right, so here's a couple more examples. This is just a little review. I'll kind of go through this quickly just to kind of show it. But so the idea is these are a bunch more examples showing the exact same thing, that anytime you have an acid and you look at its conjugate base, those two multiplied will give you 10 to the negative 14th power. And also, if you struggled with that math and how you'd actually add your exponents up, you need to do a math review. Most of the math you find, well, not most, but a lot of the math that you do on the MCAT is going to be exponent-based math or logarithmic math, which will show you how to shortcut in a little bit here. But yeah, a lot of the math that seems like it would be impossible when you see the question outright. But in reality, there's a lot of shortcuts and ways to do this faster or more efficiently. It's really, really common. Cool. All right. So let's do our first question. And so other teachers are going to grab a poll for you. You'll notice it's in the bottom of your screen where it has polls. It'll pop up in a little bit here. Thanks, it just changed. But so don't say in the chat, right? So please don't say in the chat. But I want to give you all like 30 seconds or so to think about this. Put your answer in the poll, and then I'll kind of talk it through. Give it some thought. If you've already answered, enjoy some tea. Take a little break. Perfect. All right, so what are these polls looking like? All right. Nice. I'm really impressed. We actually have about 60-ish% of the class going for the right answer, which is pretty not common actually for a question like this. It's a little tough. And so the polls are shifted around a little bit, but it's actually going up. Nice work, team. Let's talk about how we solve this. So when you looked at this molecule, H2S, you do not need to memorize properties of H2S for the MCAT. That is not what we're talking about here. But you do need to recognize that it's going to be very similar to another compound. And what compound would this molecule probably be very similar to, and why would it be so similar? And so I'm going to actually draw them both out. So if that's your picture of H2S, nice work, team. Because it's in the same group, right? This is talking about vertical columns on the periodic table. It's going to behave a whole lot like water, right? So oxygen and sulfur are really, really similar compounds because they have the same valence electron configuration. You got it. The main difference between them is just like we talked about before with chloride and fluoride is size. And so here's your second question. If you look at these two, you can see that you've got longer bonds with the SH and you got shorter bonds with the OH, just because oxygen's a lot smaller, so it has to form shorter bonds. And so what's true about short bonds? So the shorter a bond is inherently means that it will be a stronger bond. Nice. And so if thus these bonds are weaker, so SH bonds are weaker, that means that they will be easier to break. Nice call, Camilla and everybody. So yeah, so basically the idea is that SH, we know that it's going to have weaker bonds than OH, which means it's going to be easier to break. And so then that means what about the K value? Like we already know water has a K value. We call it KW because it's water. Actually, I'll have to move this. I'm going to draw it right over my head. That won't work. As we said, the K value of water is 10 to the negative 14th power. Thus, we know that the K value of whatever it is for H2S must be greater than, it's going to dissociate more than KW. Nice work. And so that's why we've got actually over 70% of us going for the right answer here. We know that it is going to be much less than 1 for a couple of different reasons. First of all, we know it's going to be greater than 10 to the negative 14th, which means it's not going to be near 0, right? That would imply that it could be tiny, like 10 to the negative 30th or 40th or something like that. It's not a tiny, tiny number. It's a decent number. But the thing is, it's not going to be 14 orders of magnitude greater than KW because these things are in the same group on the periodic table. They'll be similar, but we do know it's going to be a more dissociation than you have with a KW or with water. And so that's why it's gotta be B, not way stronger than water in terms of 14 orders of magnitude, right? Not trillions of times stronger, but also not weaker, so not near zero. Awesome. Oh man. Yeah, and we'll get to that. We'll do a bunch of negative stuff, Jillian, in a second. So actually, that's our main next focus in class here, is we want to spend some time really digging into the things that bother the most of us, and that is actually calculating numbers here. And so we're going to talk about negative logs. But before we can talk about negative logs, we want to make sure you have the foundation. Let's just talk about logs, and not the ones that travel in pairs and roll downstairs. For those of you that remember Ren and Stimpy, that might be too outdated at this point. But when we talk about logs, we'll give like what log means. Log implies base 10 if you see it written as log, where x is equal to y. So then what that means, just using these generic variables, that means 10 to the power of y will be equal to x. All right, so this right here, this is just the definition of what log means. If you did not know this, get some dry erase markers and put it on your bathroom mirror. In fact, I strongly recommend those of you that are actively working on anything, whether it's MCAT or just classes in college that include rogue memorization, like your amino acid one-letter codes or kinematics formulas or whatever that might be. Get a dry erase marker, walk in your bathroom, put the equations on your bathroom mirror, and then every time you brush your teeth or put on makeup, you'll have an opportunity to fit in a little bit more studying than you otherwise wouldn't. One thing to keep in mind if you do that, though, is try to at least once a week or once every 2 weeks at least, erase all the equations and then rewrite it up, like refresh the whole mirror with different things. Otherwise, it tends to just get caked on there and gross. Cool. All right. Yeah, good old markers, right? All right, so let's do a couple examples then. So then if I were to say that we want to solve for the log of 1,000, so what would the log of 1,000 be? Oh my God, I love Post-it notes and dry erase markers. They're the best. But so log of 1,000, that basically is the same thing as, right, 1,000 can be rewritten as 10 to the third power, or you could say 1 times 10 to the 10, right? 1 doesn't actually mean anything, but we tend to write it that way. Thus, the log of 1,000 is just equal to 3. You guys got it. Cool. So either, log of 10 to the third equals 3 or log of 1,000 equals 3. That's the exact same statement. So then what about this? Let's do it the other direction. So let's say that we have the log of 0.00001. What would that be? Be careful here. So notice, all you got to do is basically count your decimal places. You could rewrite, and actually let me erase that 3 there, because that is no longer true clearly. But you could rewrite that as 1 times 10 to the not negative third, but negative fourth. Right, so you count your decimal places, 1 decimal place, 2 decimal place, 3 decimal place, 4 decimal place. Thus, that would be equal to just -4. Yeah, so we're a little split with the decimals there. A lot of folks say -3, as I'd expect. But just make sure you count your decimals, be exact. And the cool thing is, usually on the MCAT, they're going to be nice and not give you a giant list of zeros with a decimal. They'll just say it's 10 to the -4. They tend to be pretty straightforward about this. But yeah, you got it. So that's the way that you do logs. So then to do full circle, gotcha. Yeah, totally. Yeah, it's got to be after the 1, right, Jillian? A lot of people miss that. But so if you were then to solve for the negative log of, we'll do the same thing. So the negative log, I'll just put it on the bottom here. Sorry, the screen got mad at me. So the negative log of 10 to the -4th power, right? And 1 times 10 to the -4th or 10 to the -4th, those are equivalent statements. That then would be equal to 4. Cool. All right, and so that's what we're going to do when we talk about negative logs on the MCAT. We are almost never, ever, for the MCAT, or in any chemistry that matters for life, which the MCAT's all about, going to be dealing with concentration of protons with positive exponents. You just don't see that. That would be like a acid concentration that's so strong, it'd be like the blood of the aliens in the Aliens movies, where it like melts through anything. In fact, I think it was, I think it was Aaron, another MCAT teacher, or Patrick, actually talked about this in class once and looked it up, and it was supposed to be like a pH of like -30 something, totally crazy stuff. But that doesn't matter for the MCAT because you're not going to see crazy acids like that on the MCAT because they don't exist in the real world biological systems. It is possible to make superacids in industrial chemistry. You can have negative pHs. You can have like a pH of negative 14. Seriously, that exists. But nothing in life or with water. And so it doesn't matter for us as, pre-med students and going into, biochemistry. That's more like the crazy industrial stuff. Cool. And so Lainey has a really good question, and thank you for asking that. We are going to do that in 1 second, and I will show you a shortcut to make it way, way, way easier. I'm so glad you said that. All right, but first, a couple quick little warm-ups. So if we were to look at 10 to the negative 1, so notice when you say pH, P just means the negative log of proton concentrations, right? So pH is negative log of proton concentrations. pKa is just negative log of your Ka. So all of these are just saying take the negative log of the Ka, and that's going to give you the pKa. Or as we said, you could take the negative log of your proton concentration, and that's going to give you your pH. It's the same idea across the board. So as you said, that would just be equal to 1. Or you could do 10 to the positive 8th, and that would give you a pH of negative 8, which once again doesn't exist in biological systems, but it is a real thing, and you can have negative pHs. That does exist. You're just not going to see it in the MCAT, because it would really suck if you had that in physiology. It would be very painful. All right, so as Lainey brought up, other folks as well, let's talk about when your exponents, or when your coefficients, right? So remember, the number in front is known as your coefficient, or mantissa is another fancy name for it, whereas the 8 there is your exponent. So if we vary your coefficient away from 1, things get a lot more confusing. And so here's an example. So what I want to do is show you this little trick that we here at Kaplan call the ninja trick, or there's a lot of different names for it, but most people call it the ninja trick, I found. And so here's all you got to do. And I'll give you a generic setup, and I'll actually write my own, because the one that's on screen is a little hard for some reason for folks to see, just because of the formatting. So I'm going to redraw it. But if you have some coefficient A times 10 to the some exponent that I'm going to define as B, the way that you can approximate, and so this is if coefficient isn't 1, all you do is you take your exponent, B, you subtract 1 from it, you pop a decimal in, and then you say 10 minus your coefficient. You got it. That is exactly true. And so let's give it a shot. So then basically what we do here is say, okay, exponent 3 minus 1, which gives you a 2, then a decimal, put your decimal in, and then you take a 10 and you subtract your coefficient. I'm not going to get as specific, Chiamaka, let me know if that's the correct way to say that. It's a cool name. I'm bad at pronunciations though. But super good call. Don't even deal with the 6.4. Just plug in a 6. So like 10 minus 6 will be fine. And so you can call this 2.4-ish. That is just an approximation. It's not an exact answer at any means, but this is the MCAT. It's a multiple choice test. You can round a whole bunch, as Brian's saying, and you got it. And so yeah, we just call this about a 2, about a 4. And so as you can see, there's another way that it's broken down at the bottom of the page. I've just found that a lot of students, for some reason, struggle with the way that's written in terms of formatting. So I've rewritten it for you in red to make it really stand out. Cool. All right. And let's do another one. So let's use the chat. So let us know in the chat. What then would be the case if your concentration of protons was 2, don't deal with the 0.1, just 2 times 10 to the negative 8th. So what pH would that give you? We'll just use the chat for this one. Nice work. So as you can see, you just take your exponent, which was 8, subtract 1 from it, throw a decimal in, then put in a 10, and you subtract your 2, which gives you just about 7.8, as Teresa and lots of other folks are saying in the chat. Good call. So now one thing is some people forget this little mnemonic, and so to get really, really cheesy here about a way to remember the mnemonic is what the biggest mistake people will do is everyone remembers the B minus 1, but sometimes they're like, wait, then is it like A minus something? And they get a little confused. And so just to prevent that slight confusion from happening, I'm going to draw another cheesy picture for you all to look at. But if you were to look at the center there, notice how right there in the middle, secretly, is hiding the picture of a little cat. And so if you draw your formula and you can't deep in your brain somewhere imagine this little picture of a cat face, that means that you have not written the formula right. And so maybe we can call this the ninja cat trick. I might try to officially change it to that. We'll see what the other teachers think about that as a way to remember this formula. So really cheesy, but we love cheesy mnemonics all around these parts. Thanks, Brian. I'm down to, and yeah, we'll do a couple more examples now that we got it a little practiced and a little memorized. Yeah, I was gonna say, oh my God, I recently learned that on the internet there's this thing known as a cat tax, and so if you write a really long post, you're supposed to put a picture of a cat at the bottom, which is kind of like your toll for thanks for reading my whole post. Here's a cat as your reward. Apparently that's a thing. Didn't know until just this week, but I bet some folks in the room have probably heard of this cat tax before. And so there's my cat tax for you. All right. So that's all fun and good. But sometimes they're going to be a little mean about this. And instead of giving you this trick going forward, where you have some kind of a concentration of protons that you have to use to find a pH, you have to go backwards where they'll give you a pH and you have to use that to figure out a concentration. So let's just give it a shot, actually. So in the chat, try to figure out what the concentration of protons must have been to have given you a pH of 13.3. So try to go backwards if you can. And this is tougher for a lot of people, so I'll show you how to do it in a sec here. Drink tea as the answers are coming in. So it's tougher, more varied answers. So you can see, oh, also one thing, everybody, you'll never see exponents that aren't whole numbers. So on the MCAT, they won't give you exponents of like 14 point something or any kind of decimals in there. They'll work in a calculator. You can plug it in, but you're not going to see that in answer choices because there is no calculator on the MCAT. And so since they know that, they're only going to give you whole numbers. So here's a way, in case if you didn't quite get that as quickly, you have a lot of right answers. But what I kind of like to do, and what I found most of us other Kaplan teachers do, is that we tend to write the answer down first. So we know it's going to be 13.3. And then to figure it out, you're like, all right, well, that means that your B term must have been 14 to make it into a 13 there. So you know that your B term must be 14, as we've got almost everybody actually saying in the chat. Nice work. And you know that your coefficient, right, to get a 3 there must have been 7, right? Because you had to subtract a 7 from 10 to actually get 0.3. So that would then be, of course, 7 times 10 to the negative 14th power, as most folks are saying in the chat. Really, really nice work. Cool. All right, so that's your negative log cat ninja trick, as we're going to call it now. And so I think we have one more example. Yeah, we'll do one final example here, just for good measure, to make sure we're all on the same page and now can apply that on our own. So let us know, what will you get by reverse engineering a pH of 1.8? All right, so same thing as before. I personally am a big fan, and I would recommend you all to do this on test day, on your whiteboard on test day. That's right, you get a little whiteboard booklet. You write down this formula during the tutorial. You are completely legally able to write down anything you want during the tutorial. It's actually a recent rule change that happened in the past couple of years. You used to not be able to. But so you can write that down before your before your test starts, and not actually use up any of your testing time to write it in. And so that way, if you do have to go backwards, you got it right there, and you can see exactly as Madeline's saying, your B term must have been 2 to give you a 1. So then that means your exponent must be 2. And actually, your coefficient must have also been 2 to give you an 8. So it'd be 2 times 10 to the negative 2, as almost everybody's saying there. Totally. And so, yeah, sure thing. And I've noticed this too. Like, I mean, I myself was a Kaplan student. That's why I teach for Kaplan. It was way back in 2006 at the University of Illinois, Urbana-Champaign, if we have any Illini in the room. The thing was, these problems were really, really frustrating for me. And so the reason that many of us teachers teach here is because we were students and we're like, oh my gosh, this totally works. And this is one of those things that I learned and changed my life. We'll let the other teachers give you specifics on that. We probably got a link or something somewhere. But so if you just Google it though, it's a little booklet of whiteboard. It's like a laminated paper booklet with a fine tip marker. And actually, with all the Kaplan classes that you sign up for, we'll actually mail you guys one of those included in your course. It just changed. So if you were enrolled in the past, you probably didn't get one. It's a new change. So people who just enroll nowadays, you get it with your class. So it's all included. So we'll make sure exactly, yeah, as Lee's saying, Kaplan students get one to practice with. That's identical to the one you'll use on test day. Or at least it'll be different words on it, but it's the same. So everything's the same about it. But there might be a couple different words because it's, not at a testing center. So it won't say like property of, whatever testing center on it. Cool. All right. Well, nice work, team. Let's, and there we go. Thanks, Mike. And that's a link to the agency's list and descriptions of all of that. So thanks for putting that up there, Mike. All right, so that's the big part of our class today. We got some more stuff to talk about, though, before we get out of here. And so let's do a couple practice questions. This should be fun. And so let's bring up that poll again, team. And so the other teachers will bring up a poll on the bottom of your screen there and throw your answers into the poll. Let's give them a minute to solve this one, if you don't mind. So I'll turn off my camera for a minute, let you guys solve this. We'll see what people think. Right, so we are pretty darn split, but we've got some really solid test day strategy here because the vast majority of us have eliminated answer choice B and D. I'm just going to cross those two out. So why were we able to eliminate answer choice B and D, or at least about 90-something%? Nice work. Nice. Notice we are looking for the strongest base, which means we're going to have either the highest number or the lowest number that's available here. And so one other thing to note here is that notice the values they're giving us here. These are pKa values of the ammonium. That's the protonated version of ammonia here. And so since they're giving us the values of the conjugate acid, that means if we want to have the strongest base, that means you want the weakest acid. So that's the same relationship we talked about in the very beginning of class. The strongest bases will have the weakest conjugate acids. And so that's why we actually have about 53%, that is majority, nice work, going for answer choice C. Because notice that that's the weakest acid, right? The highest pKa, right? Because remember, like Ka or pH or any of those, remember the low numbers refers to like larger values. That means it'd be the weaker acid. Thus, it would have the strongest conjugate base, which is why it is C for majority of the class. Super strong work there. Cool. And as Levi says, agreed. Tricky questions. But the thing is, even with tricky questions like this, how they're switching it around to giving you acid values, even though they're asking about bases, even with that in mind, you can still eliminate 50% of the answer choices by using critical thinking. And so that's one of the big things we focus on in all of our classes. It isn't just memorize all of these things. It's, well, if you didn't know how to solve it, how can you think critically, eliminate some answer choices, and still get a pretty good, guessing opportunity? Because if you could, I'd be curious, but if you could narrow down every single question on the MCAT to confidently a 50-50 shot and then just randomly guess, you'd probably still get not a good score, but a pretty decent score. And the more important thing is to make sure that there's a good series of questions that you're completely confident on, that you know for sure, and then the ones that you don't know, you can at least narrow it down, just increase your odds on. And so that's the way to really kind of play the game, is to think of the MCAT a lot like poker, where you got to think about pot odds. If you got to put too much time into the question, it's going against your odds, because every question's worth 1 point and only 1 point. And so if you waste a bunch of time in this one question, you're not going to have time to get all those easy questions that you could actually be 100% sure on, So it's a big part of our classes. All right, let's do another one here, and then we'll do a couple more things. This one's a bit more time-consuming, and this covers a couple of things we didn't cover yet. So let's actually give you all about a minute and a half for this one, a little bit longer, to solve question 3. We'll wipe out these polls and give you guys another opportunity to solve question 3. As you can see, we're nearing the end, so it's good to kind of dig in and do some questions. All right, good luck on question 3. All right, nice work, everybody. So what's the results we got here? I'll start kind of talking through this, because this is definitely a multi-step question. I don't think we have quite as many people voting on this. We'll see what the results are looking like, though. But let's start solving. So it says we have 50 grams of an unknown acid, molecular mass, got a Ka value, as well as a volume. So we're going to solve for pH. And so the first question I'd say is, if you ever have to solve for the pH of any solution, that means we are solving for the concentration of protons, right? Because if you have the concentration of protons, all you got to do is take the negative log, and that's doing that negative log ninja cat trick that we talked about before to give you the actual pH. So we got to figure out some kind of a way to get your concentration of protons. And so the way that we do that is actually what we talked about in the very beginning of class today. That's with our first formula of your Ka. Remember, your Ka expression is always going to be equal to the concentration of products divided by the concentration of reactants. So the your H plus minus your A minus. So that means that you're going to have to use your Ka, which was defined in the question stem. So that's awesome. Will be equal to the concentration of your conjugates times your protons, divided by, of course, the concentration of your initial acid. So now the thing is, you're always, to kind of come full circle one step further here, is that whenever you are solving for this Ka expression, since an acid dissociates into both its protons and its conjugate bases, that means that you can always solve for each of them as being the same thing. Because if you get X amount of protons, that means you're also going to have X amount of conjugate bases. Those two are equal because you can't get one without the other. So you can effectively solve for that as x squared divided by the concentration of whatever your acid is. So what's missing though? Like if we know that solving for x is going to give you protons, and with protons you can get your pH easily. And they gave you the Ka in the question stem. So we got almost everything that we need here to solve. The only thing missing is that we don't have concentration of your acid to start with. So we got to figure out how we can use weight, 50 grams, molecular mass, 200, and our volume here to figure out what our actual concentration of acid initially was. Cool. All right, so cool, there we go. All right, so let's do it. So then looking here, we have, sorry, I wanted to catch up on the chat. I lost you guys for a second there. There we go, but exactly as Alexander said, we need concentration of acid, perfect. And so does anyone know a formula that we can use to actually solve for concentration of acid, giving a mass, a molar mass, and a volume? And also Megan brought up a really good point there where the HA minus X, so that's referencing an ICE table. I'm actually not going to even go through ICE tables because on the MCAT, you can always disregard the change. So that's the minus X, Megan. Remember how back in the day you had to do the quadratic formula to figure out whether you could disregard the change or not? You guys all remember that? Like the C part of ICE tables. You are never, ever, ever going to do that on the MCAT. On the MCAT, don't do the quadratic formula. It's always going to be small enough changes that you can just disregard it. And so we kind of just disregard ICE tables when we go through classes because it won't be an important skill on test day. But yeah, as you guys are all saying, the way that we can solve for our concentration is that the think of what concentrations units are. It's molarity. And we know that molarity is defined as how many moles you have. This might be covered up, it might fit though, divided by whatever your volume is. So moles per liters, as you all said. And so if you have 50 grams with a molecular mass of 200, that means we have 0.25 moles, right? Because 50 grams, 200 molar mass, you got a quarter of a mole. And your volume, of course, is 500 milliliters, or 0.5 liters. And so we know that your concentration of acid is 0.25 divided by 0.5, and that's what we're going to plug in for that HA term right there. Cool. So, and so the thing is, if you struggle with math like this to divide 0.25 by 0.5 in your head easily, there's a lot of ways you can do this. But the way I'd probably personally do it is just multiply the top and bottom by 2, and that will give you the nice straightforward answer of 0.5 divided by 1, and that's much easier. So then we can actually just plug and chug and go from here. So let's actually just do that. So then for our HA term at the actually I'll work left from here. Clean up this a little bit to define it all. And so we said your Ka term is equal to x squared. And x squared is going to be divided by 0.5 as we just solved for. And that term is going to be equal to your Ka. We said the Ka was 8 times 10 to the negative 8th. So once we got it here, you got it. That's basically just going to be, all right, well, 0.5 times 8 gives you a solid 4, right? Because multiplying anything by 0.5 basically means you're taking half of it. So you got 4 times 10 to the negative 8th. And then that is going to have its square root taken of it, right? Because it's x squared, and that's going to equal x. And that's why we do have, oh boy, a good chunk of the people going for the right answer here. Our answer of, notice, concentration of protons is 2 times 10 to the negative 4th. And so this number that we just solved for, you got to stop and take a second and say, all right, we just solved for x. Wait a second, what was x? Why did we solve for it in the first place? That's right, x was right there. That's the concentration of protons. So now that we have the concentration of protons, we can do our NinjaCat trick and figure out exactly what it's going to be. And so just as before, you take your exponent, 4, subtract 1 from it, pop a decimal in there, then you take your 10 to make sure you got that little kitty face there. See the little kitty face? Then from that, you're going to subtract your coefficient, which is 2, and that leaves you with 3.8, which we have, what was that? Not majority, but a good chunk of class, about 40%, Brian. Thanks for the update. I crept up, perfect. I'm going for answer choice B. And so notice that even the right answer there, which is answer choice B, it's not exactly 3.8, because when you do this negative log approximation, it's an approximation. It is not exact by any means. And so remember, just keep that in mind, that we are only getting a general idea of around what the pH is, exactly as Brian's saying there in the chat, which is all you need for the MCAT. This is a multiple choice exam where you do not have a calculator. They are going to write questions such that you can do this kind of, it's not quick math by any ways. That took a while, but the kind of more mentally math with easier numbers and the approximations are definitely valid. Cool. Whoo-wee. All right, so we've only got a little less than 10 minutes left, and so there's one more thing that I'd love to run through with all of you, because I've learned in my, 11 and a little bit years of teaching MCAT, that there is one thing when it comes to acid-base chemistry that nearly everybody has this innate, I don't know if fear is the right word, but maybe dislike of, and that is the idea of normality. Now, I don't know why, but let me know actually in the chat. Does anyone happen to have this just angry feeling whenever they hear about normality in chemistry questions? And I don't know why it's the case, but I feel like this is a really common theme. And so since that's the case, what my goal will be in these next 10 minutes or a little less is to dig into normality and to show that it's actually a lot easier than people think it is. And that's the thing, isn't it? If you're saying it's really, really common, but we can actually make it kind of straightforward. And so the way that we make normality kind of easy is like the broken heart left me by. The way that we can make this easier is to define this new term. Well, it's not new, but another idea that's known as equivalents. And so equivalents are like, here's an actually, let's do an example. Best things are usually best learned by example. But so if you've got a mole of hydrochloric acid, that means you have an equivalent of acid. So what this is really just doing is it's looking for how many protons you get. So to give a bit more of a like a hard definition, so to speak, of what equivalents mean, is that if you say you have one equivalent of acid, I'll type this in purple because we love purple. So one equivalent of acid is the same thing as 1 mole of protons. So that's the idea. So when we say that 1 mole of HCl gives you 1 equivalent of acid, it means you got a mole of protons. So then if we've got a mole of something like sulfuric acid here, then how many equivalents or how many moles of protons do you get with this single mole of sulfuric acid? And you do need to memorize the formula for sulfuric acid for the MCAT, as well as phosphoric, and all those other ones we talked about are really huge. But exactly, Hannah and everybody, that would give you 2 equivalents of acid. Perfect. So now you can also have this in the context of base. And so here's an example of a base. This one's a bit more straightforward, but let us know in the chat what would be, if you had 1 equivalent of this calcium hydroxide, how many equivalents of base would you have? And so I'm going to type something in while y'all are saying that in the chat. 1 mole of base, it's not necessarily 1 mole of hydroxides. It means sometimes that there's 1 mole of hydroxides, but exactly as Brian's saying there, spot on, it could also mean 1 mole of protons being accepted. Because that's what hydroxides do. They are going to react with protons and basically accept them is the word that we use there. Totally. So yeah, it's a mole of calcium hydroxide is going to give you 2 equivalents of base because those 2 moles of hydroxides can pick up 2 moles of protons. So let me give you a weird example that relates to biochem. So remind me, everybody, whenever you see a kinase, what does a kinase do? Because, oh my gosh, it's biochem and enzymes are really important for the MCAT. But so nice, one of the things that kinases do is that, or not one of the things they do, what kinases do by their definition is that they add phosphate groups. And so phosphate has the formula of PO4 3-. Nice. And remember, it's a transferase as well. Good call, because it's a type of transferase. That's what a kinase is. That's phosphate groups. And so phosphate, then if you have 1 mole, actually, let's not do 1 mole. Let's say you have 3 moles of phosphate. So if you have 3 moles of phosphate, then how many equivalents of base do you have? To give one more example here. So 3 moles of phosphate implies that you have, notice since each one of these has a -3 charge, that means each phosphate can pick up 3 protons. And so 3 moles of phosphate means you have 9 equivalents of base. So for bases, sometimes they're going to be nice and easy, and they'll give you things that actually form hydroxides. If they're going to be nice, but they're not always going to be nice and give you these logical hydroxide guys. Instead, sometimes, and nice call everybody, they're going to give you charges instead. And just be aware, if it's got a -3 charge, it means you can pick up 3 protons. Thus, it'd be 9 equivalents, as Bex and everybody's saying in the chat. Got it. Cool. All right, so that's the idea of equivalence. We're going to use equivalence now to talk about 2 things that you have to do calculations on. Gram equivalent weight and normality. We'll end with normality because that's the classic that a lot of people just don't like. Oh man, right? Don't be ashamed. We've all been there. That's the thing. All of us have, spent lots of time studying for and taking the MCAT in the past in order to teach. It's necessary. But most of us took Kaplan classes, and this is where we learned how to do this stuff in the first place. And so we all start off getting tricked and not knowing things. It doesn't matter where you are now. All that matters is you put the time in to learn these kinds of things and learn from your mistakes. And so that's why the main thing that we stress for every student is really take full-length exams and learn from the mistakes that you make. It's the only way we can get better at this. And that's why we're teaching this now, so we can teach it to you beforehand, so you won't make the mistakes the first time you take your full lengths, and you'll start off at a higher score. That's why we do these fun events. All right, so let's do gram equivalent weight first, and then we will jump into normality last. And so when you talk about gram equivalent weight, I know that this looks really confusing, but really all gram equivalent weight is saying, and we'll give the breakdown. I'll put GEW for gram equivalent weight. W as it's written right there. So what this really means is how many grams it takes to get a proton. Or you could say, or except for a base, same idea. Right, so whether it's an acid or base, it's the same idea, but it's how many grams it takes to get a proton. That's what it's all about. Awesome. All right, here's the cool thing. If sodium hydroxide is monoprotic, or I guess it's monobasic for this one, if it's 40 grams per mole, then how many grams does it take to get a mole of hydroxides, or to pick up a mole of protons, if you wanted to find it as picking up protons? Well, since it's monobasic or monoprotic, whatever you want to call it, and it's 40 grams per mole, well, then it's going to take 40 grams of sodium hydroxide's dry weight to actually give off 1 mole of hydroxides. It tends to be straightforward. Yeah, exactly right, Deborah. Where it gets more confusing is if you've got something like calcium carbonate. So now, sorry, sodium carbonate, not calcium carbonate, but either way, it'd be the same answer. And so the thing with carbonate is you need to know for the MCAT, or even if you don't even know, well, you do, but you should recognize here that since it has 2 sodiums bound to it, that means carbonate has a -2 charge. So you want to know that about carbonate. That should just be memorized. But notice that you don't need to know it here. They tell you by a sodium how many negative charges carbonate has. So then, how many grams of sodium carbonate will it take to give off just 1 mole of hydroxides, or to pick up just 1 mole of protons, given its mass here? And so notice what we're really doing here. You can see people saying it in the chat. But all you have to do to solve for gram equivalent weight is just divide. Han and Levi got it. So it's divide molar mass by equivalence. So if you've got something like phosphate that's tribasic, divide by 3. If you've got something like carbonate that's dibasic, divide by 2. And so it's really just divide whatever your molar mass is by the number of equivalents that you get that we talked about in the previous one. So yeah, a lot of people in that lane totally true. A lot of people multiply, but not for gram equivalent weight. For gram equivalent weight, we divide. Now the cool thing is, when you look at normality, once again, this formula looks complicated, but really all you're saying for normality, I'll leave it up top here, normality refers to the molarity of protons. Once again, you can also talk about the molarity of protons being accepted, but it's really just another term for molarity of protons. That's why its actual unit here is equivalents per liter. how many equivalents you get in any single liter. So for example, if you've got this one here of sulfuric acid, if your concentration is 0.1, right? So 10 to the negative 1, you can also call it 0.1. Then what's the normality? So notice all you're really doing for normality is just, now instead of divide, multiply your molarity by equivalence. Thus, if your concentration of actual sodium hydroxide, not sodium hydroxide, sulfuric acid, sorry, sulfuric acid here, your actual concentration of sulfuric acid is 0.1 or 10 to the negative 1, then all you got to do is multiply it by 2 because you get 2 protons per molecule of sulfuric acid. So it'd be 2 times 10 to the negative 1, or, as Deborah's saying, 0.2. So let me give you one more question before Petros jumps back on, just to make sure we're all on the same page here. You're right, it is 0.2. You're totally right, because there was the concentration was 0.1, right? So you're totally right at 0.2. But let's say that you have we'll do something crazy like a 2.5 molar solution of phosphoric acid, H3PO4. So if you have a 2.5 molar solution of phosphoric acid, that means your normality must be, what do you think in the chat? So remember, all you got to do is take whatever your equivalents are, which in this case is you get 3 protons per mole, multiply that by your molarity, which is 2.5, giving you exactly, as Brian says, his survey says, 7.5 normal. And remember, all that normal means is how many equivalents you get per liter. That's like the definition of what normality means. Cool. All right, everybody. Well, it's been so much fun hanging out with you and really nerding out, talking about acid-base chemistry, the secrets of the world, so to speak. And so we'll be hanging out. I'll be hanging out in the chat with you guys after here. But Petros is going to hop back on. Before, I guess I can get a little segue before he jumps back on, just to remind you that what matters most with what you're doing right now is that you are practicing for this exam. Don't just study for the MCAT. You got to make sure you're practicing and actually doing it. And Petros is going to talk a lot more about the ways you can do it, what it looks like, and give you some strategies for that. But it's been really fun working with you all, and so I'll hop off cam, and Petros will jump right on. Yeah, it's been great working with you all.
All right, thank you, John. And what do you guys think? That's pretty awesome stuff that we have going on. Can you? Don't know what's going on with the camera here. All right, that should be working. How's everybody doing? Welcome back. Sorry about that. So what I was saying was pretty awesome stuff that we saw there. And as John mentioned, all this stuff definitely shows up all over the MCAT. It shows up all over the place, and really something that's important to be mindful of and to be very much part of your preparation. I wanted to kind of highlight a couple of things for you in terms of kind of what you just saw. That was, as we said earlier, a session directly from the MCAT channel. And John is one of our instructors on the MCAT channel. So when you're in a Kaplan class, you'll see John all the time on the MCAT channel. It's pretty awesome stuff, as it were. But more importantly, what I wanted you to kind of pay attention to or kind of reflect on from what you saw in the last hour is how is it that all these little topics, how they have to all come together. Remember what I said earlier? What was the key point that I said earlier? And I see a couple of you already typing this in as far as what you saw. It's the application, right? The application of the material is what's really, really important on the MCAT, and that's really where you get all your scores. So we're going to talk a little bit about that kind of as we go here. But here's the deal: this is time for you to ask your questions. So I want you to be typing in the questions that you have as far as like what to do and when to do it as far as MCAT prep is concerned. I mean, that's what we're all here for. We're all MCAT teachers, and we're all here to get those questions answered for you. But before you do that, what I do want to make sure that you do is enter yourself for the $100 Amazon gift card, because we're going to select the recipient of that here in a couple minutes. So I'll give you another minute or so to put that in, and then I think Brian's going to do the honors of pulling a name from the hat, and then we will announce that at the end of today. So with that said, let's talk a little bit about kind of what a study plan really needs to entail. First and foremost, as you are preparing for this exam, there's a lot of content that you are going to need to cover. That is a given as far as the MCAT. That is kind of a requirement. There's a lot of content that you're going to need to make sure that you are brushing up on, getting refamiliarized with. It's really easy to forget this stuff, right? Who's forgotten some of the content, even some of the content that you saw today? Did anybody kind of feel that moment of, oh no, I used to know this stuff, or I remember learning this stuff at some point, and now I have forgotten it? Did anyone kind of get that feeling along the way here? Because I'm sure a couple of you did, because I know I do all the time, right? We're like, oh, I know I knew this at some point, but let me relearn this along the way. So that's really important to kind of keep in mind, is that you're going to be learning a lot of content, reviewing a lot of content, but that's really going to be earlier on in your preparation. If you kind of think about your preparation path towards the MCAT, earlier on there's a lot of content review, and then you slowly start to need to layer in more and more practice. So you need drills, you need realistic practice, and you kind of build yourself up to full-length exams. And what I see a lot of, and I've been doing this for the last 19 years, what I see a lot of mistakes that students make is they start off taking full-length exams. They think, all right, I'm taking the MCAT, I better go take a full-length exam right from the get-go, where in fact you haven't really built that endurance level yet. So when you think about your study plan, you need to know what your starting point is. You need to kind of know where you're at right now. And that's not just in score, that's in kind of your overall content familiarity, your comfort level with your content. And you want to know, of course, where you want to end up. You want to have a target score. And the worst thing that you can do for yourself is to go into your college textbooks. If we take kind of a typical organic chemistry textbook, it's got like 1,200 pages in it, right? Physics books, they've got 1,200 pages in them or so. They're huge amounts of material. All that material is not tested on the MCAT. There's a very kind of finite blueprint that the MCAT will test you on. And that is, quite frankly, in our courses, we only cover the material that you are going to be tested on in the MCAT. In fact, our materials only cover material that you're going to be tested on in the MCAT. I've had lots of conversations through the years where students will say to me, but Petros, I learned X, Y, or Z in my physics class. Why aren't you guys covering it? Well, we're not covering it because the MCAT isn't going to actually test you on that material. So important to kind of make sure that you're kind of following a right plan. But at the same time, you have to start to learn how to take this test. And the little trick that John showed you, it's not a little trick, it's a big trick, that John showed you as far as calculating pHs, that is a classic example of a better way to attack problems specifically on the MCAT, on a standardized exam like this, that's going to have multiple choice answers where you don't have to produce a precise answer. You need to find an answer that is close to the correct answer, because there's only going to be one answer that's going to be that close, and therefore you know that it is the correct answer. So building out those strategies and really learning those test strategies and getting practice with them is going to come by drilling yourself and starting to get more and more realistic practice. And we're really happy that we were able to offer, I think, somewhere in the neighborhood of now 10,000 plus questions that are all realistic looking MCAT questions that are part of our course. And you want to definitely get lots and lots of practice with full-length exams. Now, in terms of full-length exams, to be clear, you don't want to be doing these from day one, right? You don't want to be doing these from day one. You want to be doing these at a very kind of prescribed time, which is usually somewhere in the neighborhood of about 7-8 weeks before your actual MCAT is when you want to start taking full-length exams, and you want to be doing them about one exam per week, right? So really important to kind of keep that in mind as well. So you kind of get yourself into this rhythm as far as one full length. So for those of you that are taking the test here in April, hopefully you've been already doing that. For those who are taking the test in May, there's still time to get into that rhythm of taking full length exams. And then for those of you testing later down the line, definitely you have that time to incorporate that into your practice. And then of course you want to have somebody who's been through it before. You want to have that expertise. So tap into the source of expertise. When you're in a Kaplan class, you're going to have your core instructor, you're going to have your channel instructors, you're going to have a team of folks who are going to be available to you to really kind of help you along the way as far as the expertise is concerned. Now, when you start to think about kind of what's in a Kaplan program, I won't bore you with the details. You can find this information out on our website, but it's important to recognize that we've got a lot to offer. And we have a lot of things that our students are going to be doing as part of their preparation. So, bottom line, we give you the most live instruction that's available. So really, what that's going to mean is you're not going to run out of live instruction. But I want to be very, very clear here that it's different for everyone, right? So if you're a rock star in thermodynamics, you're not going to need as much practice or as much live instruction on thermodynamics. You're going to want to kind of flex that out and say, you know what, I'm not so great at, I don't know, resistors. I saw a comment in the chat about resistors not being applied to the heart, which is something that is relatively important, especially when we think about defibrillators and such. So bottom line, you're going to need to make sure that you're kind of picking and choosing the right content that's good for you. The last thing I want anybody doing here is just looking at their friends and saying, well, my friend, she did this, therefore I'm going to do that as well. I mean, make sure that you're extremely kind of, I don't want to say selfish, but really prescriptive to what your individual needs are. And that's where our program really comes into play, is that we have a core set of classes, but then something like the MCAT channel, and then all of our other resources, very, very customizable. So you get the personalized instruction that you ultimately need, and you get the practice that you ultimately need. I mean, there's a misprint on the slide because we now have 15 full-length exams as part of our course. And so the AMC recently added a full-length exam, and that's been added into our program. You actually get all the materials from the AMC. So important to kind of keep that in mind as well, but also recognizing that we've got your back. I mean, bottom line, our goal is to get you the score that you want to get on the MCAT. And so we have a higher score guarantee. We guarantee that your score will improve, or you can continue to study with us, or we'll even give you your money back. It's plain and simple like that. So lots and lots of opportunities available for you. One nice feature of our Plus programs is actually the personal MCAT coach. So what we do in our Plus programs is we pair you with an MCAT expert who works with you one-on-one for 3 hours. It's different from tutoring. I saw a couple of questions that came in privately about that. So it's a little different from tutoring. Tutoring is, you go through specific subjects. What our MCAT expert coaches do is actually coach you through your MCAT studies. They're kind of like a personal trainer, right? So you've got your plan. We've got our smart reporting system that kind of prescribes things to you, but then you can work with an individual who's going to really, really kind of dive deep into a very, very personalized study plan with you. So you actually build a relationship with that individual coach along the way, as it were. So what you saw today was the MCAT channel. And the MCAT channel, I've been alluding to this all night, we've got about 100 or so elective lessons, which go from kind of foundational concepts up to advanced high yield concept areas. But the cool thing about the MCAT channel is that it's actually on every night. So we have a rotating schedule of channel sessions. There's actually an MCAT channel that just ended for the evening here tonight. But the MCAT channel, what it does is it kind of constantly rotates through this these series of lessons, and it's taught by our top 10 faculty here at Kaplan. So really, really exciting from that perspective, because you get access to the best of the best out there, and it's available to you, and you kind of pick and choose the sessions that you need to go to. So this is back to that notion of the personalization level. Here you see Eli Schwartz, one of our MCAT channel instructors. You just saw John, who's teaching a session there. So really important to kind of keep that in mind, is that you do have this opportunity to kind of pick and choose the instruction that you are ultimately going to need. So you're not wasting time doing the things that you don't need to do, and you're spending time doing the things that you do need to do. As far as practice is concerned, I saw some questions as far as practice specifically. Really, it's I mentioned this earlier. We've got over 10,000 total practice items available as part of our program. One really cool new feature, we've always had a quiz bank, but now we have an adaptive quiz bank. And what adaptive quiz bank does actually takes quiz bank to the next level. What happens is you will tell the quiz bank the number of questions and the topic area that you want to work on. But then what the quiz bank will do is it will give you questions, it will adapt to your performance. So it will give you questions that are challenging you so that you're ultimately learning more and more along the way. So the adaptive quiz bank technology is something that's relatively new here at Kaplan, and it's super awesome. Really, the best way to experience it is to try it out. But really, what it does is it allows you to kind of hone in your skills. So you're always being challenged. You're not wasting time working on stuff that's too easy. You're not wasting time working on stuff that's too hard. You kind of work yourself up to those materials, up to those levels as far as your preparation is concerned. So here's what I want you to do. If you've got whatever questions that you've got on your mind about our programs, about preparing for the MCAT, all the things, I want you to type those into the chat. So this is a great opportunity for you to get all your questions answered. So type those in, and then we're going to be answering those for you here, really to make sure that you're doing the right things at the right time, especially those of you that are testing relatively soon. There's still plenty of time to kind of get your full preparation in. So type in those questions and let's see what you've got on your mind. I see a couple of questions. Karina, I see questions. Where do you find the full-length exams when you're in the MCAT Prep Plus? You can find the full-length exams. Actually, they're all over the place, but if you look on the kind of side of your syllabus, on the left-hand side, I will say additional resources, and you can find your full-length exams there. Lainey, great question or comments, maybe a little bit of both. Having a really hard time with cars. Here's the deal about cars. Cars are actually a cool thing. I'm glad you asked the question. So cars is the one section on the exam that truly has no previous content knowledge required. It has no previous content knowledge will help you on the cars section, right? So you can know everything there is to know about a cars passage, but that's not actually going to help you get any more points. What it comes down to for cars, and really this is a skill that works in the other sections as well, is being able to read the material, read the passages, and extract the core argument of why each paragraph was written and why the passage as a whole was written. So what is it that the author is trying to convince you of? What is it that the author is trying to convince you not to do? Whatever it might be, whatever the argument it is that the author is trying to make, that's what cars is testing you on, being able to identify that. If you're able to identify that, then you can answer almost every single problem, no problem, right? With no problems. So part of that also comes down to the fact that there are lots of different types of questions that show up in the cars section. We actually categorize them in our smart reporting system. Actually, the shot that you see on the screen right now, what the smart reporting system will do is it'll actually identify for you what it is that you're missing, right? What are the areas, what are the types of questions, what is it that you're missing so that you know what you can ultimately be improving on. So really, best way to practice for cars is to practice outlining the passages. That's a skill that we teach you in class. But another great kind of top tip is just read a lot. Read stuff that is of high level. I mean, I'm talking like, The Economist or the New York Times. Like that level of writing is the type of reading that you want to be practicing with. And the more you do that, the better you will do. There was a question of whether or not the full-length exams, the Kaplan full-length exams, change from one year to the next. They change ever so slightly. What we do every year is we do a full psychometric review. We actually just completed one not too long ago. So we make sure that our tests are still in line with the actual exam based on the blueprint that's published by the AMC, based on the sample questions that are published from the AMC. So we make little edits here and there, but for the most part, that's about it. We're not rewriting all 11 full-length exams. The AMC definitely doesn't do that with their practice materials, but we make sure that we're constantly tweaking it and making sure that you're getting an accurate reflection. Because the whole point of taking the full-length exams, I alluded to this earlier, is not necessarily the score you'll get, it's the practice you'll get and making sure that it's realistic practice. So we want to make sure that you get the realistic practice all the time, right? That's really a big important part of your preparation along the way. And really get the practice that you need, and more importantly, get the instruction or get the get your course in the way that you need. I saw a couple of questions come in as far as like different course options. we've got lots of course options. So here's the deal. Best way for you to figure out what's right for you is for you to have a conversation with us. So there's that link at the top of the screen. Click on that, and you can schedule a time to speak with one of our expert instructors to kind of help you figure out what the right courses for you. I mean, we've got courses that are live online. That's this environment here. Courses that are in person. Courses that are self-paced. So if you don't want the live instruction, you just want the self-paced instruction. And then of course we have tutoring, right? So we've got lots of different ways to get you, lots of different ways to get you, prepared for this exam, but more importantly, kind of make it work for you. So if you're, really busy and you can't commit to a given schedule, maybe self-paced is right for you. If you like the live instruction, but you don't want to physically go to a location, or there isn't a location, a live classroom location near you, live online is perfect. In fact, live online, oddly enough, is actually more interactive because you've got multiple instructors in the room. I mean, right now, you've got 6 instructors that are in the room with us total, as opposed to being in an in-person environment where it's just you and the instructor at the front of the board or whatever, as it were. So really, really important to kind of keep that in mind. Lainey, there was a question, good question. Do I think that the AMC materials are the most accurate? The AMC materials, at least the full-length exams 2 and 3, which are the more recently released practice exams from the AMC, those use questions that were on the MCAT, but I wouldn't say that they're any more accurate than even our full-length exams, simply because, like anything, the MCAT even varies from day to day. In fact, the MCAT varies on the same day. If I took the MCAT and you took the MCAT on the same day, we wouldn't get the same questions. So, as I said earlier, what we've done is we've gone through to make our tests, our full-length exams, all of our practice questions really reflective of the MCAT to get you the practice and the level that you ultimately need to get as it were. So really, 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 really important to keep that in mind as you're going. So something to keep in mind. Hasha, great question. You get all of AMC's previously released materials as part of our course. So that's something that we have built into our program. You actually even access them directly from your Kaplan syllabus. You don't have to go to a separate place. You just click on a button and it takes you over to the AMC materials as it were. So as it's going. So anything that's available from the AMC, you don't need to get those separately. Very important to kind of keep that in mind. Jake had a great question as far as how much work should I do prior to starting an in-person Kaplan course, and this will work on your own. The reality is this, and I say this because I mean, genuinely, we want you to do well on this exam. Bottom line, you don't want to do too much work before you start your prep because you can very easily form bad habits. So not really a good thing to do. You don't want to form bad habits. So what we recommend for students to do is as soon as you enroll, you get your book shipped to you. You can take your diagnostic exam and you can actually start coming to the MCAT channel. That doesn't mean your class has started yet. So maybe you're testing in September and your class, you want it to start in June or July. Maybe if you're in school and you want, kind of to take advantage of the summertime where you don't have a whole lot going on. So very simply put, once you enroll, you can start kind of dabbling here and there in our materials. And, that's where you can start to see the work to do. Because really what it comes down to, it's not about how much work, it's about making sure that you're doing the right work. So general recommendation is to kind of get yourself enrolled, and then from there, figure out what the path is. The cool thing when you take the diagnostic exam, what happens is we actually give you an analysis of what your recommendations are. We say, here are the recommended assignments that you should be doing. So you as an individual student should be doing along the way. So, you kind of can use that as your guidance of what, work you should be doing between now and when your formal classes start. You can start coming to the channel, start, utilizing the resources as it were. And really, that's the big part of it. There's a chart here because I know there are lots of options, and this actually isn't on our website as far as a nice one flow chart. But if you wanted to kind of see what's included and what. That's what we have available. So if you're thinking of doing like a self-paced plus course or an MCAT prep plus course, you can see what's available as far as those different pieces go. Really, really important to kind of keep that in mind. Ruby had a question as far as score deflation in the Kaplan exams. No, there's no deflation. There's no inflation. We actually have a team of psychometricians, which are very, very smart people who analyze our full-length exams against performance on the real tests and performance as far as the real tests are concerned. So you get a nice, accurate reflection. Here's the deal, though. I've been doing this for a long time. I can tell you for a fact, there's always score variations. I mean, you will see minor score variations. Even if you took a real MCAT today and a real MCAT tomorrow, you would see minor fluctuations as far as the score. So that is something that will happen. But they're not going to be huge fluctuations, as it were, along the way. All right, so that's what we got in terms of that. Another kind of last thing, I saw a couple of you were thinking of prepping this summer. We do have our summer intensive programs, and actually I should just call them our intensive programs because we offer them year-round. We will have a live online summer intensive program as well as in-person summer intensive programs. These are different from our core programs. What summer intensive allows you to do is pretty much get a 5 or 6 week intensive, don't do anything else. Really, it's kind of like MCAT summer camp or MCAT boot camp, and it's a really, really cool experience, but it's extremely focused as well. So the idea behind the intensive programs is that you isolate yourself from everything else as you're working through this along the way. So with that said, I wanted to announce our Amazon gift card recipients. So drum roll, please. The drum roll goes to Holly Morales. So Holly Morales, congratulations. You've been selected to receive a $100 Amazon gift card. We will be in contact with you within about 24 to 48 hours. So expect to hear from us, but congratulations to Holly. Use it well. Use it. Have some fun with it. Maybe even if you'd like, because that's there for you. So that's the bit. John is one of our intensive program gurus. In fact, John, you're leading the Boulder intensive this summer, if I remember correct. Oh, you've been doing it for the last many years, so I'm sure you're doing it again. I know you're doing it again. So definitely come join John if you want Boulder for some fun there. So great. Good stuff. Well, if there are any final questions, we will be around for a couple more minutes to answer your questions. I mentioned this earlier, but just always remember, Kaplan, we do guarantee that your score will improve, or we'll give you your money back, or you can continue to study with us for free. You can see all the information about that on our website as well. But with that said, I want to take this opportunity to thank everyone who was here, and especially take a moment to thank Allie, Brian, Greg, Henry, John, of course, Mackenzie, Mike, and Rich, who've all been here with tonight's event, making this happen. But I wanted to thank each and every one of you because you guys have been great. I saw how actively you were participating during the class time with John. Really, take what you've learned here tonight and use it, whether it's even specific to acids and bases, because some of the stuff that we saw wasn't just about acids and bases. Those are skills that you can be using across the board. We will be back tomorrow with another free event. We're going to be doing light and optics. So hopefully I get to see all of you here tomorrow night. I'm excited about tomorrow night because I get to kind of flip roles and get to teach. So it's going to be a lot of fun to do that as well. So looking forward to seeing all of you here again tomorrow. If you have any final questions, by all means, please do let us know in the chat. We'll be more than happy to get those answered for you along the way. Also, just a quick reminder, if you are thinking about taking a Kaplan course, today's actually a really good day to get yourself signed up because we actually have a little bit of some monies off. Use the code SPRING200 when you go onto our website. You can save yourself $200 off of our program. So by all means, if you're thinking about getting signed up and you haven't already done so, today is a good day to do so. So with that said, I hope our paths will cross again. If they don't, I wish you all the best of luck on your MCAT and on your road and journey towards wearing a white coat. Thank you again for joining all of us. If you have any final questions, feel free to type those in or schedule some time to speak with one of our experts on the phone, and we'll help you figure out what's right for you. Thanks, everybody. Have a great rest of your evening.